As it turns out, in the last video, I ended up doing all the examples I wanted to for addition and subtraction. So this one's just going to be about multiplying. So let's talk about multiplying with radicals. We've already done that, but we're basically talking about multiplying polynomials. Okay, so let's look at this. Okay, so we've got the square root of 5 plus 4, the quantity, the square root of 5 plus 4, times the quantity of the square root of 3 minus 6 times the square root of 2. What a mouthful. But guys, this is just foiling what we already know so well. This times this, then this times this, then this times this, and this times this. It's just that it's got some more stuff in it, but don't worry about it. So now we've got the square root of 5 times the square root of 3. Well, because they're both square roots, we can multiply, and they're multiplying. I only need to worry about the indexes. Unlike when we're adding, I need to worry about what's underneath as well. If we're multiplying, I just need to worry about the indexes being the same. So that's the square root of 15. Then I've got the square root of 5 times the square times negative 6 times the square root of 2. So that's going to be negative 6 times the square root of 10. Take a minute, make sure you understand why. Then we come back and we're going to do 4 times the square root of 3. Well, about the only thing, it's kind of like multiplying 4 times x. I just get 4x. But this is 4 times the square root of 3. And then 4 times negative 6 times the square root of 2. Well, it's the whole numbers I'm multiplying here. So first of all, a negative times a positive, is a negative. 4 times 6 is 24 times the square root of 2. Now I need to see if there's anything I can combine. Well, they're all square roots, but I can't reduce the square root of 15. I can't reduce the square root of 10. I can't reduce the square root of 3, and I can't reduce the square root of 2. So this is my final answer. That's as much as we can do. Now, let's look at this. G minus 7, G plus 7. Take a minute, look this over. What do you notice? You better all be jumping at this and saying, this is a difference of squares. My x's are the same, my y's are the same, my signs are different. So when it's x plus y, x minus y, it goes into x squared minus y squared, difference of squares. So g squared minus 49. Okay, that's not with any radicals though. We're going to do the same thing with radicals. Remember, I've said that these patterns, difference of squares and perfect square trinomials, come up all the time. Well, let's look at this. The quantity 4 minus the square root of 7 times the quantity 4 plus the square root of 7. Well, guess what, guys? It's a difference of squares. My x's are the same. My y's are the same. My signs are different. So I take my x, which is 4, and square it. That's 16. I know in a difference of squares, that's going to be negative. And this is the square root of 7 squared, right? But remember from before, when the exponent and the index match, the base of our exponent falls out. So the square root of 7 squared is 7. 16 minus 7 is 9. That's it. We're done. Okay? Let's look at some more. Okay? So 4 times the square root of 3, the quantity 4 times the square root of 3 plus the square root of 2 times the quantity 4 times the square root of 3 minus the square root of 2. Again, this is just a difference of squares. You just need to realize 4 times the square root of 3 is your x, square root of 2 is your y. Signs are different. So 4 times the square root of 3 squared. Well, 4 squared is 16, and it's multiplying with the square root of 3 squared. Well, the square root of 3 squared is just 3. And then minus, because in a difference of squares, it's always minus. And the square root of 2 squared is going to be 2. 16 times 3 is 48 minus 2, so my answer's 46. Okay, we've got 2 more examples for this one. The quantity, the square root of 2y plus the square root of z times the quantity, the square root of 2y minus the square root of z. Again, just a difference of squares, guys. That's it. My x's are the same. They're both the square root of 2y. My y's are the same, the square root of z, and my signs are different, positive and negative. So I just take the square root of 2y squared, and so we've got the square root of 2y squared. Remember, when the exponent and the index are the same, the base of my index falls out. So that's 2y minus, because in a difference of squares, it's always minus. And then the square root of z squared is going to be z. Nothing more I can do with this guy. Okay? And one more. Okay? 2, the quantity 2 plus the square root of 5 squared. Oh boy, guess what? This one is a perfect square trinomial. And so, remember, a perfect square trinomial is x squared plus or minus whatever this guy is, not both, one or the other, and then 2 times x times y plus y squared. Well, the 2 is my x, and the square root of 5 is my y. So my first term is x squared, so that's 2. 2 squared is 4. Then plus, because this guy's plus, and then 2 times x times y. Well, the square root of 5 times 2 is 2 times the square root of 5, and then I multiply that times 2. That just equals 4 times the square root of 5. So I get 4 times the square root of 5. Then my next sign is positive, because in a perfect square trinomial, that second sign is always positive. And then I just take my y, which is the square root of 5, and I square it. So the square root of 5 squared is 5. Well, now these two, the 4 and the 5, are like terms, so I can add those, and I can't do anything more with the 4 times the square root of 5, so my final answer is 9 plus 4 times the square root of 5. Okay, let me do one more. I wasn't going to, but I will. We'll do the square root of m minus the square root of 3 squared. Oh, another perfect square trinomial, where the square root of m is my x and the square root of 3 is my y. So I take my x, which is the square root of m, and I square it. So the square root of m squared is m minus, because this guy's minus, my middle term is 2 times x times y. So that's going to be my x times my y. The square root of m times the square root of 3 is going to be the square root of 3m. And then I multiply that times 2. Well, there's nothing more I can do with it except write 2 times the square root of 3m. I've done everything I could. And then my second sign is positive, because in a perfect square trinomial, my second sign is always positive. And then I take my y, which is the square root of 3, and I square it. So the square root of 3 squared is 3. And I'm done, because there are no like terms. So be sure to watch. I mean, sometimes there's no pattern, like did we have, oh, like this guy up here, okay, our first one, number 1. But then always watch for difference of squares and perfect square trinomial patterns. And that's all there is to this section.